Problem 12.76 involves a particle mass m projected from point A right here with initial velocity of v naught, perpendicular to the line OA right here, which has a separation distance of r naught, and moves under a central force F shown right here along a semicircular path. So this is a half a circle right there of diameter OA. Observing that r is equal to r naught cosine theta and using equation 12.25, show that the speed of the particle is v equal to v naught over cosine squared theta. Now, looking at our drawing right here, you can see that this line right here, which is line back to the origin and OA, and then the line going from A up to the particle, they form a right triangle. And so that's a right angle right in there. So keep that in mind. This line right here is going halfway across this. So this is a radius right here. And that's a radius right there. And that's a radius right there of the circle. So this is an isosceles triangle right here. So if this angle is theta, that angle right there is theta as well. We're going to be looking at the angle between the direction of the velocity and the direction of r, because when you write out the angular momentum as r times mv times sine phi, that's the phi that we're looking at. Now I want to make a note of something right quick. If we take a look at this line right here and that line right there, they form two perpendicular lines. If we freeze those lines together and rotate them through an angle theta so they're right there, then that's going to line up with this line and that line right there. And so therefore this angle right here is theta. Let's keep that in mind for later on. So we're given r naught and v naught, and r is equal to r naught cosine theta is given to us. We're also given equation 12.25, which says that r squared theta dot is equal to h. We want to show that v is equal to v naught over cosine squared theta. So let's look at v sub r first. V sub r is r dot, which is the time derivative of r, which can be expressed as r naught cosine theta. So when you go into here and take the time derivative, because r naught's a constant, you're going to end up with r naught sine theta with a minus sign and a theta dot right here. And if you look at v sub theta, it's r times theta dot, which means it's r naught times cosine theta times theta dot. Then the velocity is the square root of the sum of the squares of the components there. And so we have the r component right here. When you get squares, it's going to be r squared theta dot squared sine squared theta. And this right here is going to be r naught squared cosine squared and a theta dot squared. And if I said r up here a while ago, it's r naught actually. So when you take a look at this, you can see that r squared and theta dot squared can factor out of here, and you're left with sine squared plus cosine squared, which can be 1. So v is equal to r naught theta dot. So all we got to do is get theta dot in terms of the givens that we have. So up here at the top, we've given r squared theta is equal to h, but this is a conservation of angular momentum, so it's also equal to r naught v naught. And the r squared right here is rewritten as r naught squared cosine squared theta. So when you solve for theta dot out of here, you're going to get r naught v naught divided by r naught squared cosine squared theta right there. And one of these are going to go away. And so you're going to end up with you're going to end up v naught over r naught cosine squared theta. If you take the r naught over here and multiply times theta dot, then you're left with v right here, which means that v then is equal to the rest of this stuff, which is v naught over cosine squared theta. Now, an alternate approach to this is looking from the drawing up there that we were talking about earlier. If you take a look at that, the angle phi is 90 degrees plus theta. So if we got 90 degrees plus theta, that implies that sine of phi is going to be equal to cosine theta. And from your conservation of angular momentum, you're going to have r naught v naught equal to rv sine phi, and r is r naught cosine squared theta times v. So when we solve for v out of this, we're going to be left with v naught over cosine squared theta. It took a long time in class today to realize that this angle right here is finally theta, but it's really easy to see again. If you look at this line right here and the line representing the velocity vector, they could form like two perpendicular lines. And if you freeze those and rotate that like a coordinate system, rotate it to an angle theta right here, then you will be looking at this line right here and that line right there being perpendicular to each other. So that angle has to be theta. And that allows us to go ahead and write that phi is equal to 90 degrees plus theta and finish out the problem.